Voyager 1, the furthest man-made object from Earth, continues to inspire awe and curiosity as it journeys into the vast unknown. Launched in 1977, this spacecraft has traveled further than any other human creation, reaching an unimaginable distance of 24 billion kilometers from our planet. Despite the incredible distance, Voyager 1 is not slowing down. It hurtles through the dark expanse of space at a speed 14 times faster than a bullet, an enduring testament to human ingenuity and the pursuit of discovery. However, in November of last year, Voyager 1 went silent, raising concerns that the mission might be over. Yet, in an astonishing feat of engineering, NASA revived the spacecraft just weeks ago, bringing all systems back online. Voyager 1, it seems, will live to explore another day. This unexpected revival prompts several fascinating questions. How much longer can Voyager 1 continue its journey before its power is depleted, and contact is lost forever? And if it could take another snapshot of Earth, akin to the iconic image captured in 1990, what would it reveal now? Perhaps even more intriguing is the thought of Voyager's future. Thousands, maybe even millions of years from now, when humanity might no longer exist, could something or someone else find Voyager 1? What would they think of this relic, drifting silently through the cosmos? To explore these questions, we need to trace Voyager 1's remarkable journey, understand the challenges it faces, and imagine its future, both as a scientific tool and as a symbol of humanity's eternal quest to reach beyond our world. A journey beyond the solar system. Voyager 1's odyssey began on September 5, 1977, when it was launched into space to explore the outer solar system. The mission was designed to take advantage of a rare planetary alignment, allowing the spacecraft to use gravity assists to slingshot from planet to planet. Its primary objective was to study Jupiter and Saturn, two of the gas giants that dominate our solar system. However, as the mission progressed, it became clear that Voyager 1's potential extended far beyond these initial goals. It would continue on an uncharted course, eventually leaving the solar system and entering the vast, empty regions of interstellar space. The scale of Voyager 1's journey is difficult to grasp. To put it in perspective, the distance between Earth and the Sun, about 150 million kilometers, is known as an astronomical unit, (O). Voyager 1 traveled 5.2 astronomical units, around 780 million kilometers, in just over a year and a half, reaching Jupiter and capturing stunning images of the gas giant. This was only the beginning. After another 3 years, the spacecraft arrived at Saturn, sending back even more breathtaking data and imagery. But after this encounter, Voyager 1 embarked on its long, lonely voyage out of the solar system. For 31 more years, Voyager 1 traveled at an astonishing speed of 61,000 kilometers per hour, eventually passing the heliopause, the boundary where the Sun's influence ends, and interstellar space begins. This marked the spacecraft's entrance into a region that no other man-made object had ever reached. The heliopause, though a significant milestone, is not the edge of the solar system. Beyond it lies the Oort cloud, a vast sphere of icy bodies that surrounds our solar system and marks its outermost limits. As of 2024, Voyager 1 is approximately 163 astronomical units from Earth, more than 4 times the distance between the Sun and Pluto. At this incredible distance, it takes over 22 hours for a radio signal to travel from Earth to Voyager and another 22 hours for Voyager's response to return. Despite how far it has traveled, in the grand scheme of the universe, Voyager 1 has barely left our cosmic neighborhood. It will take another 300 years before it reaches the Oort cloud, and it could take up to 30,000 years to completely pass through it. Only then will Voyager 1 truly leave the solar system and begin its eternal voyage among the stars. Now, imagine Voyager 1's path not just decades or centuries from now, but millions, or even billions, of years into the future. As it drifts through the galaxy, what mysteries will it encounter? And what if, long after humanity is gone, another intelligent civilization finds it? Voyager 1's journey, while nearing its end from a human perspective, may only be beginning on a cosmic scale. Maintaining contact with a distant traveler given the immense distances involved, one of the most remarkable aspects of Voyager 1's mission is that we are still able to communicate with it. But how do we maintain contact with a spacecraft that is so far away? NASA relies on the Deep Space Network, DSN, a global system of massive radio antennas located in California, Australia, and Spain. These stations are strategically placed to ensure that communication can be maintained with Voyager 1 at all times, even as Earth rotates. When NASA sends a command to Voyager, it takes over 20 hours for the signal to reach the spacecraft. Voyager's onboard computers then process the instructions and send a response, which takes another 20 hours to return to Earth. The signals that Voyager sends back are incredibly faint, transmitted by a radio with a power level of just 20 watts, the same as a refrigerator light bulb. Despite this, the DSN's massive 70-meter wide antennas, along with smaller 34-meter dishes, are sensitive enough to pick up these weak signals and relay data about Voyager's environment back to Earth. But time is taking its toll on Voyager 1. In November 2023, the spacecraft began sending back random strings of data that made no sense. Conspiracy theories quickly emerged, with some speculating that aliens had captured the spacecraft and were using it to communicate with Earth. The reality, however, was far less dramatic. NASA engineers traced the problem to a malfunction in Voyager's flight data subsystem. After diagnosing the issue, they sent new instructions to Voyager, waited patiently for the response, and were relieved to find that the spacecraft had recovered. Voyager 1, it seemed, had survived yet another challenge. The looming power shortage. While communication with Voyager 1 is still possible, the spacecraft faces a far greater challenge: it is running out of power. Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs, which convert the heat from decaying plutonium into electricity. However, as the plutonium continues to decay, the amount of electricity the RTGs can produce diminishes over time. NASA has been gradually turning off non-essential systems to conserve power, including heaters and scientific instruments that are no longer needed. Unfortunately, this has also meant shutting down Voyager's cameras, which have not been operational for years. NASA predicts that Voyager 1's power supply will continue to dwindle over the next few years. Eventually, there will not be enough electricity to support even the most critical systems, and the spacecraft will go silent. When that day comes, Voyager 1 will continue to drift through space, but it will no longer be able to communicate with Earth or send back any data. It will become a ghost ship, silently gliding through the cosmos, its mission complete. The pale blue dot. A last glimpse of Earth. One of the most iconic moments in Voyager 1's journey came in 1990 when the spacecraft, already billions of kilometers from Earth, was commanded to turn its cameras around for one last picture of our planet. Carl Sagan, the famous astronomer, had been campaigning for this image, arguing that it would offer a profound perspective on humanity's place in the universe. Many at NASA were skeptical, seeing little scientific value in the effort. But Sagan's persistence paid off, and the result was the now famous, pale blue dot, photograph. In this image, Earth appears as a tiny, insignificant speck, just 10% of a single pixel, floating in a beam of scattered sunlight. Yet, within that speck is everything we know. Every person, every civilization, every story ever told. The pale blue dot serves as a humbling reminder of how small we are in the grand scale of the universe, and how fragile our existence is. As Voyager 1's power dwindles and its operational life nears its end, one can't help but wonder what another photograph might show. If we turned the spacecraft's cameras on one last time, what would it capture now? The sun would appear as a faint, blurry dot in the distance, surrounded by the planets of our solar system. This image would not just be a snapshot of Earth, but a family portrait of the entire solar system, a final farewell from Voyager before it goes dark forever. Voyager's legacy. A message to the stars. While Voyager 1 will eventually stop transmitting, its journey is far from over. The spacecraft will continue its voyage through the Oort cloud and beyond, traveling through interstellar space for billions of years. As it drifts further into the galaxy, it carries with it a message from humanity, the Golden Record. This disc contains sounds, images, and music from Earth, along with information about our location in the universe. It is a time capsule, a message to any intelligent civilization that might one day discover Voyager. The Golden Record includes greetings in multiple languages, the sounds of animals, and even a baby's cry. It also contains mathematical equations and scientific data, providing clues about our technology and where we are located in the cosmos. Voyager the 1st of May goes silent, but it will still serve as a beacon of hope, a reminder that humanity once reached for the stars. When the day finally comes, and Voyager 1 stops sending data back to Earth, we can take solace in knowing that it completed its mission and much more. It has given us unprecedented knowledge about our solar system, sent back